Modern warfare has always been decided by two ledgers simultaneously. The first is the military ledger, territory taken, targets destroyed, forces degraded. The second is the financial ledger, the cost of the weapons fired, the cost of the weapons used to stop them, and the industrial capacity required to replace both. Throughout most of the 20th century, these two ledgers moved in rough parallel. The side with superior military capability also possessed superior industrial capacity, and that industrial capacity could sustain the financial demands of prolonged conflict. What the retaliatory strikes launched by Iran on the evening of February 28, 2026 demonstrated, with a clarity that will not escape the attention of strategic planners in Beijing, Moscow, or Pyongyang, is that this parallel no longer holds. The two ledgers have decoupled. And when they decouple, the side with superior technology does not automatically win the financial attrition contest. Iran's retaliatory salvo combined ballistic missiles and loitering munitions, what are commonly called kamikaze drones, in a coordinated wave targeting Israeli and Allied positions across the region. The specific composition of the salvo matters less for this analysis than the economic architecture of what was fired and what was used to stop it. Because the most consequential number from the evening of February 28th is not a body count or a damage assessment. It is a ratio. The cost-exchange ratio is a concept that defense economists have used for decades to evaluate the financial sustainability of air defense campaigns. It compares the unit cost of an attacking weapon with the unit cost of the interceptor used to destroy it. When that ratio exceeds 1-to-1, when stopping a threat costs more than launching it, the defending party faces a structural problem that cannot be solved by tactical excellence alone. Iran's Shahed series loitering munitions, which formed a significant portion of the retaliatory wave, carry an estimated unit production cost of approximately $20,000 to $50,000 per airframe. These are not sophisticated weapons by the standards of modern aerospace engineering. They are essentially large, slow-moving drones built around commercially available components, guided by basic GPS navigation, and designed to fly toward a target area and detonate on contact. Their effectiveness is not derived from individual precision or speed. It is derived from volume, from the saturation logic of sending enough of them that even a highly capable air defense network cannot intercept everyone before its interceptor supply is exhausted. Russia's use of Iranian-supplied Shahed drones against Ukrainian infrastructure beginning in 2022 provided the first large-scale documentation of this strategy in modern combat. Ukraine's air defense networks, drawing on U.S. Patriot systems, German Iris-T batteries, and a range of shorter-range assets, intercepted a significant percentage of incoming drones throughout 2023 and 2024. But the financial mathematics of that campaign were deeply unfavorable to the defending side. Every Patriot PAC-3 interceptor fired to destroy a $50,000 drone represented a net expenditure of approximately $4 million, an exchange ratio of 80-to-1 against the defender. The February 28th retaliation combines this drone saturation logic with a harder layer: ballistic missiles that require more capable and more expensive interceptors to defeat. Israel's Arrow 3 system, developed in partnership with Boeing and operated by the Israeli Air Force, is designed specifically for the exoatmospheric interception of ballistic missiles at altitudes above the atmosphere. Its estimated unit cost per interceptor falls in the range of $2 million to $3.5 million depending on the production batch and the specific variant. David's Sling, which covers the medium to long range ballistic threat layer below Arrow 3, carries interceptors estimated at approximately $1 million per shot. The U.S. Navy's SM-3, deployed from Aegis-equipped destroyers in the eastern Mediterranean and the Persian Gulf, represents an additional layer at a unit cost of between $10 million and $27 million, depending on the variant. The SM-3, Block 2IA being among the most expensive interceptors in any Western inventory. Against Iran's ballistic missile inventory, where a Shahab 3 variant costs roughly $500,000 to $1 million to produce, even the most conservative exchange ratios run 3-to-1 against the defending coalition. Against the drone component of the salvo, the ratios are far more severe. The financial consequence of a single night of intensive air defense operations at this scale is not difficult to model. A salvo of 150 ballistic missiles at an average Iranian production cost of $700,000 each represents a total attacking expenditure of approximately $105 million. Intercepting that salvo, assuming a 90% intercept rate requiring 165 interceptors, averaging $3 million per shot across the mixed Arrow and David's Sling inventory, represents a defending expenditure of approximately $495. But a 99% intercept rate against a salvo that costs the attacker $100 million requires an interceptor expenditure that may approach $500 million or more, and the attacker can rebuild its salvo capacity in weeks. The defender's interceptor stockpile takes years to replenish. This brings the analysis to the second structural problem exposed by the February 28th retaliation: the industrial production mismatch between offensive drone economics and defensive interceptor manufacturing. An Iranian Shahed 136 drone can be assembled using components sourced from international electronics markets, commercial-grade navigation hardware, and a relatively small, low-skill manufacturing workforce. The production timeline from raw materials to operational weapon is measured in weeks. This is not a coincidence of Iranian industrial capacity. It is a deliberate design philosophy, one that Iran has been developing and refining since at least 2016, and that it transferred to Russia for use in Ukraine, providing real-world operational data on the saturation strategy's effectiveness against NATO standard air defense. A Patriot PAC-3 interceptor, by contrast, requires specialized solid-fuel propulsion components, precision-machined seeker heads capable of terminal homing at hypersonic velocities, advanced electronics manufactured to aerospace-grade tolerances, and a production chain managed primarily by Raytheon Technologies at its facilities in Tucson, Arizona. Raytheon's leadership has stated publicly that the company's current production capacity for Patriot interceptors is approximately 550 missiles per year at full output. The Red Sea campaign of 2023 and 2024, in which U.S. Navy destroyers fired more interceptors in combat than in the previous decade combined, drew down stockpiles at a rate that the 550 per year production figure cannot rapidly offset. The February 28th retaliation accelerates that drawdown further. Expanding Patriot production meaningfully requires factory floor expansion, new supplier qualification for restricted components, and workforce training, a process that Raytheon and the Pentagon have both publicly estimated at 24 to 36 months minimum. The strategic implication is precise and unavoidable. Iran can sustain its offensive capacity through industrial processes that operate on a weeks-long cycle, while the Western defense industrial base is constrained to a years-long replenishment timeline. The cost-exchange ratio is not merely a nightly accounting problem. It is a compounding structural disadvantage that grows more severe with each salvo launched and each interceptor fired. The third signal from the February 28th retaliation moved not through the atmosphere but across the surface of the Persian Gulf, and its financial consequences are among the most global. A missile flying at 30,000 feet over Iranian territory, or over the Persian Gulf itself, is sufficient to halt a $100 million oil tanker on the water below, not through physical impact, but through insurance mathematics. The mechanism is straightforward, but its consequences are vast. A tanker operator cannot legally sail a vessel without valid war risk insurance coverage. A bank financing a cargo cannot release funds without proof of coverage. A charterer cannot commit to loading schedules without a credible transit timeline. When active ballistic missile exchanges are occurring in the airspace directly above and adjacent to the world's most critical oil transit corridor, underwriters at Lloyd's of London and the international group of P&I clubs, the 13 mutual insurers that collectively cover approximately 90% of the world's ocean-going tonnage, face an actuarial environment in which new risk issuances are impossible to price with any defensible methodology. The response in such environments is not to price higher, it is to stop pricing entirely. A freeze on new war risk policy issuances for Persian Gulf transit was already observed in the hours following the initial February 28th preemptive strikes. The commencement of active ballistic missile exchanges over the region in the retaliatory phase transforms that freeze from a precautionary pause into a structural halt. The economic consequence flows through the system with mechanical precision. Tankers already loaded and at sea face an immediate decision calculus, continue toward the strait against the certainty of voided coverage, divert to holding positions outside the Gulf at significant cost, or wait at anchorage in the hope that conditions improve before demurrage charges and cargo obligations create their own financial crisis. Tankers scheduled to load at terminals in Saudi Arabia, Kuwait, the UAE, and Iraq face cancellations as charterers invoke force majeure clauses, legal provisions that excuse parties from contractual obligations when extraordinary events make performance impossible or economically irrational. The 1980s tanker war, which ran from 1984 to 1988, provides the deepest historical reference point for understanding how an extended period of Gulf shipping risk translates into global energy economics. During that conflict, insurance premiums for Gulf tanker voyages reached levels 300 to 400% above pre-war baselines. Shipping companies that could not absorb those costs simply exited the route, reducing effective tanker supply to the Gulf even without any physical blockade. The combination of reduced tanker availability and spiking freight costs contributed to oil price volatility that was felt in consumer fuel markets across Europe, Asia, and North America throughout the period. The February 28th environment differs from the 1980s tanker war in one critical way that amplifies rather than reduces the risk. Global oil inventories entering this period are substantially tighter than they were in the mid-1980s, when strategic petroleum reserves in the United States and IEA member countries were at higher relative levels, and global demand growth was slower. A disruption to Hormuz transit today ripples through a supply system with significantly less buffer capacity, meaning that the time between a shipping freeze and a visible consumer price impact is shorter than historical precedent might suggest. Energy futures markets registered this reality within hours of the retaliatory salvo reports crossing trading terminals. The psychological component of the Hormuz risk premium is analytically distinct from the operational component, but no less real in its market consequences. Traders pricing oil futures are not simply calculating current physical disruption. They are pricing the probability distribution of future disruption, and that probability distribution shifted sharply upward on the evening of February 28th. What emerges from the synthesis of these three signals, the cost-exchange ratio in the sky, the industrial production mismatch on the factory floor, and the insurance paralysis on the water, is a picture of what strategic analysts call financial attrition. Financial attrition is distinct from military attrition. Military attrition measures the degradation of an adversary's ability to fight. Financial attrition measures the degradation of an adversary's ability to afford to fight, and, critically, the degradation of the broader economic system that sustains the political will to continue fighting. Iran's retaliatory strategy on February 28th was not designed to achieve military victory in a conventional sense. No realistic assessment of Iranian capabilities suggests that a ballistic missile and drone salvo could destroy Israeli or American military capacity in the region. It was designed to impose costs, measurable, compounding, and asymmetrically distributed costs, on a system that is far more expensive to defend than Iran's system is to attack. The Western defense industrial base is structured around the assumption that superior technology justifies higher unit costs because the quality differential translates into decisive military advantage. That assumption remains valid in many domains. But in the specific economic contest of interceptor attrition against cheap, volumetrically produced offensive weapons, the quality premium becomes a financial liability rather than an advantage. The stress test administered on February 28th to Western interceptor stockpiles, to the insurance architecture of global energy trade, and to the political economies that must fund the replacement of expended inventory, will be studied with considerable attention by every state that has reason to consider how it would contest American or Israeli military power. Not because the retaliation succeeded militarily. By the metrics of physical damage and military objective, the intercepting coalition likely performed within expected